Hello, this is a short presentation about the 2024 pre-release program for the AQA A-level computer science exam. The program this year is called Symbol Puzzle. Hopefully you'll have read the pre-release already about this. I'm going to assume you have, but you quickly summarise. You've got a two-dimensional grid. You have different types of symbols, and if you form the appropriate shape, you score points. Okay, and some of the grid squares are blocked with these @ symbols. You're not allowed to place symbols on those. So the program is relatively straightforward compared to previous years. There are 4 object classes in the program. There is the puzzle class, and this contains a series of patterns. In the standard game, there are 3 patterns: Q, T, and X, and it also contains a grid of cells. Depending on the size of the grid, that determines the number of these cells here. The cells themselves are actually stored in a list and not a two-dimensional array. We'll come back to that later on. Block cells are a slightly different type of class. They inherit from cell, but obviously do not allow you to place symbols on them. Okay, so let's have a look at the program itself. So starting off in the main routine, it asks you to begin with whether you want enter a file or not. If you don't type in anything, it will run this. It'll instantiate the puzzle this way and build a puzzle from scratch, a random puzzle. Otherwise, it will use the file you've specified to build the puzzle. Okay. So as I say, there are 2 overloaded methods. They're called depending on the parameter pattern, and the file one, as I say, just uses the file name. Things go a bit wrong when you run the puzzle if you don't put in a file name that actually has the data you need in it. I'm sure you'll realize that when you play around with the program yourselves. The files themselves are looking like this. So here you have the first number is the number of symbols, the symbols themselves, then the number of patterns and the symbol patterns. And then that is the number 5 determines the size of the grid, and in there you have a load of values for each of the cells. And the first thing here is the actual value that's in the cells, and following that are the list of symbols not allowed in that cell. At the end, you have your current score, and that last number is the number of symbols you have left to play in the game. So that's the file. Let's actually have a look at the instantiating a game that doesn't use a file. You have to pass it 2 values. You have to pass it the size of the grid, which in the default game is 8, and then there's this calculation for the number of it seems to be set to be 60% of the number of cells in the grid. So an 8 grid is 8 by 8, 64 cells, and 0.6 is you're going to get that number of attempts at completing the grid. Okay. Obviously, we could play around with that 0.6 to make it give you fewer or more attempts or goes at putting in symbols. Moving on then, so it will create this 8 by 8 grid. This bit of code here does that. It instantiates a bunch of cells and adds them to the list. Sometimes the cell is a block cell, and this line of code will determine that. Hopefully that you can appreciate means that 90% of the time the cell will be a normal cell, but 10% of the time in the random game the cell will be blocked, although you have no idea where those block cells would appear until it's done. Looking at instantiating a cell then with that line of code, what it does, it places an empty value in your standard cell, and then creates a list of all the other symbols you're not allowed to place in that cell. and that is a list. Okay, so obviously they want you to be able to not to enter more than one type of symbol into this cell at some point. For block cells, it's similar. Not familiar with that bit of code. Then that means basically run the cell constructor code first before you run your own blocked cell code. So what you do differently in the block cell is to place an @ symbol into the symbol that's on the cell, and it obviously overrides the check all symbols allowed to always return false. Basically, you can't put any other symbol in that cell. Okay. Said that this grid of cells is actually stored in a list, so obviously we need to be able to move between the grid position as a row column and the position in the actual list itself, and for that we use this get cell routine that does the calculation to convert row and column to the list position. A quick look at that. So let's assume that this is our calculation up here. Imagine I type in 4,3, so I'll put my X in there. Where will that appear on the list? Well, let's have a look. So I've said row is 4, so grid size you'll see is 5. So 5 minus row is 1. And then I multiply that by the grid size. So 1 times 5 is 5. And then I add the column number, which is 3, and subtract 1. So that gives you a total of 7. So the actual, this here would be placed in location 7. Okay, we'll do one more. If I said 5, 1, 5 minus 5 is 0 for the row. So, and then column 5, column 1 minus 1 is 0. So that's actually going to go there in the 0 location of the grid itself. But just to the list itself, but just to appreciate that we don't have a two-dimensional array or anything. We have a single list of grids. So this guy's job is to convert from row and column to grid position. Okay, so let's carrying on then. The next job is to in the creating routine is to build the patterns. There are 3 patterns: Q, X, and T, and I'll just quickly show you that in the puzzle. So here's the puzzle. So what we're doing now, we're looking at this bit of code here where we build what patterns we're allowed to use. Okay, so the good question you might want to ask is why, when it says the pattern for Q, which we know has to be that in the grid here, Q, 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 and a Q in the corner, why does it look like that rather than what you'd anticipate it being that? Well, I think an important thing to realize is when we go and build these patterns or check these patterns, we actually check the 3x3 grid in this weird way, which is to start in the top left and sort of spiral into the middle. If you did that, you get Q, Q, star, star, Q, star, star, Q, Q, that pattern, which actually is the one here. So the reason it's like that is because of the way it checks the 3x3 grid. Okay. Then we attempt the puzzle. This will loop until there are no symbols left, and your count. Remember, every time you take a symbol, one goes off the number of symbols left count. At the end of the loop, it will return your score. In the loop itself, it collects the user's choice of row, column, and symbol. I've put in brackets, this could be better. There's not a lot of validation going on here for various reasons, and so that's going to be something to look at. It gets the cell from the list at the location using our get cell routine that we talked about before. And then it checks to see if the symbol is allowed for this cell, using that, and then it will check if actually you've managed to create a successful pattern using this check for match with pattern routine. Okay, so let's just quick look at this. So after you've loaded in the puzzle, you go to attempt puzzle. That's the loop I was talking about. You you do some entry of column and row number. You get the symbol. You deduct one from the number of symbols that are left. You get the cell from the list at that position of get cell, and then you check if there's any if the symbol you've entered, which is symbol, is allowed for this cell, and if it is, we do this. This is probably need a little bit more of a look now. Okay, this returns a score, and if the score is added to the total score, if it's greater than zero. I don't know why that's needed, because zero added to the score wouldn't have an impact anyway. But hey ho. So how does that check for pattern work? Well, it's got a bit of work to do. So let's just have a quick look at this. I'm just going to put this onto slideshow to demonstrate. So let's assume I placed an X here at position 5, 4, row 5 and column 4. Then what I'd have to do, I'd have to check whether a pattern had been made in various locations. I'd have to check this 3 by 3 grid to see whether that was an X. There was an X pattern in here. That's 1, and there, or here, or here, or here, or here, or here, or here, or here. So you notice that there's 9 different 3 by 3 grids to check for any symbol I place in the pattern. Okay, so you'll see that in action in the check for match with pattern, where there's this nested loop which changes the top left hand corner of the checking area each time. Okay, and if you there's a 3 in this row, there's 3 loops in this, that's a total of 9 3 by 3 grid checks to do. And I mentioned this before when we talk about patterns. There's this bit of code that goes through building up a pattern string from what's in the cell at each of these 9 positions. Okay, and notice the order in which it does it. It goes sort of like that, around in a loop, in a sort of spiral pattern, to build the pattern. It then, having got the pattern, it checks if it matches any of the patterns that are in the allowed patterns, this thing here. So if it says for all the allowed patterns, the Q, the T, and the X pattern, does the pattern I've just built match it? If it does, then I have to do all this. Okay, what's going on here? Well, the important thing to realize, if imagine you've made a pattern, what that code is doing is making sure that X is not allowed in any of these 9 cells. So it goes through all 9 cells and puts X in the symbols not allowed, because you're not allowed to place the same symbol again in the 3 by 3 pattern area. Okay, so if we just go back to our code, you see all this in action here. So let's just quickly jump to this guy. So here is the code for all I was talking about. There's 3 by 3. Look, there's sort of 9 different patterns to check. The pattern is built each time. There's a try and catch around here in bit C#, which means if it goes off the edge of the grid, imagine I placed my X in the top left hand or the bottom right hand corner, then going to some of these positions would cause an out of index bounds error. So the try catch is there to stop that. And then, having done that, if any of the patterns I've built matches the symbol patterns, then I return 10 marks, and I stop you from entering the same symbol in any of the 3 by 3 grid locations for that. If all that fails, I return 0. Nothing has been scored. So that's a summary, I think, of what I consider to be the key elements of this program. Obviously, there's other stuff in here that you can be looking at. But I think if you understand those major principles of how it works, then I think you should have a good understanding of the program and maybe what the challenges are going ahead and aiming to improve that program in the future. Thank you.